Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be talking a little bit more about Euclid's elements, and I'm going to be discussing book 1 and proposition 1 in particular. So if we look at Euclid's actual proof over here, it's very convoluted, and it really doesn't have to be this long or this verbose or anything like that. And I'll tell you why in a second, why it doesn't have to be that way. So all we have to do to prove that one can construct an equilateral triangle is that we can take a length AB of any size, here this length AB, and we can draw, or we can construct a circular path. Well, actually, we can't really construct circular paths, but a circular path does exist around the point A, which is one end of the length, such that its radius is equal to AB, and similarly with the circle E, which has also that same radius. And then, of course, the circles will meet, and they'll meet in these 2 points. And why? Because simply this, we know that they both pass through the center of each other's space. So, for example, we know that the circle will meet the circle because it passes through the center here, and this circle will meet the circle because it passes through the circle here. How do we know they'll meet at 2 points? Well, it's pretty simple. We know this from the fact of circle symmetry. Now, symmetry doesn't, in this context, mean measure with numbers. It means objects with the same parts, exactly the same parts. And what are those objects with exactly the same symmetrical part? These red arcs that you see here, okay? So these are the red arcs that you see, which are symmetrical. And there are actually 2 equilateral triangles, as you can see. Now, Sir Thomas Heath was a little bit of an idiot at times, and I suppose arrogance can do that to somebody who thinks he is exceptionally bright and really is quite an average Joe. So he says here, when he reads this thing about the circles cutting one another, he says, the assumptions that the circles do indeed cut one another should be counted as an additional postulate. That's absolute rubbish. In fact, there were no postulates at all in Greek mathematics. And so it's rubbish because the truth is that if they cross each other's centers, they're going to cut, and we know they're going to cut, moreover, in 2 points because they're symmetrical. Okay, and now let's look at this article. This article is called There Are No Postulates or Axioms in Mathematics, and it's actually a 28-page article to which I will place a link to in the detail section, and it shows you what Euclid should have done before he started writing the elements, okay? So this is what Euclid should have done before he started writing the elements. And you'll see that it takes about 12 pages before we can even get to the definition of the circle, okay? So all this previous stuff is where we start from nothing. We start from an empty universe, okay? An empty universe, and we derive every one of the requirements naturally, okay, without making any assumptions whatsoever. There are no assumptions. There are no axioms or postulates. We cannot have beliefs in mathematics because mathematics is about facts, not beliefs. Now, if you see this definition here, if you say that a circle is a path from which any shortest distance to the center is a straight line, that's insufficient to define a circle. And why is it insufficient? I'll tell you why. Because if you take any sphere with the curve, with a path like this on its surface, all these are circles. All these little red paths here on the surface of a sphere, they're all circles, okay? So what makes it a circle, the object that you're thinking of? Well, very simply this. It says that not only is the shortest path to a given point called the center the same straight line, also that same straight line must, if extended, meet the circle path again. So as you can see in this case here, you would have to take this, let me just get a pen. If this was a circle path, you'd have to first go to the center and then go by the same distance on the line, and then it must all fall on the circle, the same circle, you see. So it's insufficient to state it without using requirements 1 and 2. Okay, you need requirements 1 and 2. And what is requirement 1? That there is a shortest distance between 2 points. And requirements 2, what is that? It means that you can extend or diminish that shortest distance without changing it from being a shortest distance. Okay, so these things were revealed by me. In fact, I don't even think Euclid bothered to write them down because he thought they were so obvious, which is a shame. And also, in his Elements, he really does things very much the long way. This is totally unnecessary of Euclid, and he should have done better than this. In fact, he uses a circle in many other postulates, and then suddenly again in certain postulates, certain propositions like 4, he doesn't use a circle. And look how long and obfuscated this proof is. And again, all these proofs are based on circles. Now, you cannot have a triangle without a circle. And you may ask me, well, that sounds absurd. No, it's not absurd, because triangles consist of angles. Okay, you cannot actually have any geometric object without a circle. That's a big statement. Okay, so, and I'll prove it to you in one line. Where do you think the concept of angle comes from? Okay, it comes from a circle. You cannot have an angle, all right, unless you define an angle from a circle. Okay, so what is an angle? An angle is basically an arc length, this arc length. So if we look at this angle here, right, between this line and this line, it's equal to this arc length divided by the radius. Okay, and it's and in the 300, well, in a full circle, all those angles are unique because all those ratios are different. Okay, so it doesn't matter what the circle is, all those ratios will be different, and moreover, they will be in proportion because the arc that you're looking at is in proportion to the radius, okay, for that angle, right? So those things are all preliminary and should have come in a prologue before Euclid started his writing down his elements. Okay, so I'll elaborate a little more on these when I show you proposition 2, which proposition 2 is this one, which Sir Thomas Heath claims is a hard proposition, which is absolutely nonsense. It's very easy. He says this proposition admits a number of different cases depending on the relative positions of the point A and the line BC, and that's obviously rubbish because it deals with all cases, and I will show you in a future video why that is so. Very well then, I'm John Gabriel. This is a new calculus channel. Till next time, goodbye.